Hi there, this is video 1.5. This is the second part of counterexamples. So this is find the example, counterexample 4. Sum of 4 consecutive numbers is equal to twice the last number. So sum, you remember, is plus. Consecutive just means one after another. So 1 plus 2 plus 3 plus 4 is equal to twice the last number, 2 times 4. So 1 and 2 is 3. Plus 3 more, 6, that's 10. What? Sorry, I prepped this and there wasn't supposed to be. Well, it doesn't, so ta-da, I found the counterexample. I was pretty sure this one was supposed to work out all the time, but there we go. Counterexample, first try. All right, let's try the next one. The sum of a multiple of 9 and a multiple of 27 must be a multiple of 9. So 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 99. Not very exciting. All right, so now I got 27. Where can I move my calculator so you can see? There you go. Times 2 is 54. Times 2 is 108. Okay. Well, I'm going to tell you the secret. This one is you're never going to find. So there's no counterexample. And I can say that because I know that basically every third one of these (27 times 3) this one is always going to fit because 9 already divides it to 27, so there's always going to be a multiple there. We will get into this later on when we get into the proofs, so we can show that there's never going to be a counterexample. But that leads us to a problem. How far do we go? Right? In the previous video, I finally gave up, well, on the video part, of looking for a difference of a multiple of 711 that wasn't either odd or divisible by 3, because I did about like 8 or 9 and I haven't found one yet. So I'll look at that offline and there'll be an answer in the thing. But when do you stop? And that's another one of the problems with using conjectures. Because one counterexample is enough to disprove your conjecture. Invalidate, if you want to use a fancy word. On the positive side, it may allow you to revise your conjectures. You might be able to make a bit of a change. You might have something where you, I don't know, where you said they're all your answers are even, and you might be able to up it and say, well, no, all the answers are actually divisible by 4. So you might be able to revise it somehow, or you may have to discard it. Okay, you can never be sure of inductive reasoning. This is huge because you can't go through all possible combinations. All right, if you're looking for a sum of 2 numbers, I don't know, sum of 2 even numbers, and it's supposed to be even. Well, how long do you keep trying and making sure that they're even? Is it good when you've done 3? Is it good when you've done 10? Do you need to do 40? Do you need to make a computer program and do thousands? Yeah, you never know. There might be something out there somewhere. All right. But a hint, just in general, when you're looking for counterexamples, if you don't have any other thing to guide you, always try to do a variety of things. Try whole numbers, decimals, numbers less than 1, 0, negative numbers, really big numbers. If you try a bunch of those options, then if you can't find your counterexample, it's probably not out there. Okay. Or you can do nice systematic gathering of evidence. Okay. And what I mean by that, let me just pull up the sheet. Okay, this is from the last video, and I was supposed to find the difference between the multiples of 7 and 11, and it's either even or divisible by 3. And I did 1, 2, 3, 4, 5, 6, 7, and I gave up. But I was trying to do it systematically, right? I was doing them in order, and I didn't get an answer, so I was just randomly trying to pair up numbers, and it wasn't working either. So what I'm going to do later is go through a whole bunch more and then start going 11 and 14, 11 and 21, 11 and 28, like that, and be a little more organized. And then we'll see if we can find that counterexample that we're looking for. That's what I mean by systematic gathering of evidence. Okay, so in general, science works this way. You do your observations, you come up with a question, you come up with a hypothesis, you do your test. Now, once you do the test, you might be able to carry on and do a conclusion that, yes, my hypothesis is right, or you might have to go back and rework your hypothesis. Or your conclusion, maybe my hypothesis was incorrect. So science does that too. It doesn't mean that you're done and with one round of it. Every time you are doing an experiment, there's usually the chance that if your hypothesis does not come out correct, you can rework it and possibly retest. All right, last one here. I stole this one out of your textbook. Sorry, you can't see it that well. But it was, if you put 2 points on a circle, it creates 2 regions. So this is region 1, and this is region 2. If there are 3 points on a circle, 1, 2, 3, 4 regions. There are 4 points, 1, 2, 3, 4, 5, 6, 7, 8. All right. And then they went to colored, and it's really hard to start counting. It was 15, so I'm seeing 2, 3, 4, 5, 6. Doubling, 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 and it didn't. So here is your counterexample. Expected 32. Okay, so I had to go to 1, 2, 3, 4, 5, the 5th example before it fell apart. And how many examples are required to consider a conjecture true? I don't know. I mean, again, that's the problem with conjectures and inductive reasoning, is you can never, ever, for sure, say it's true. So I bet mathematicians have figured out a way so they can prove it works in every single case.